Hello students. So we are starting the chapter sound, chapter number 11, class 9 CBSE. So this is very important chapter and the last chapter of physics. So this is the last chapter which is sound, and interesting fact is that you all have heard the sound of anything, any object. Okay, so about that we are going to discuss. We know that in our surroundings the surrounding is filled with air, right? There is something water, somewhere it is solid medium like iron, right? Like our sand, this kind of materials are also present. So sound can travel through both kind of mediums, means maybe solid, maybe gas, maybe liquid, it can travel. But medium is essential, means you have heard that in moon there is no such kind of communication through air medium or through the atmosphere, right? Atmosphere of moon, because atmosphere of moon there is no such kind of medium, it is totally vacuum, right? So for sound essential thing is medium. So need of medium and no need of medium, as per this we can classify any wave into two types. So any kind of waves can be classified into two types. First one is what? Transverse wave, and second one is longitudinal. So for transverse wave there is means no need of any kind of medium. Okay, no medium is required, no medium. But here medium is compulsory in case of movement of the sound or any wave which are longitudinal in type. For them some kind of medium is necessary, but in case of transverse wave no kind of medium is essential. Okay, longitudinal, for longitudinal example is what? Sound wave, about which we are going to discuss in this class. And in case of transverse wave, what is the example of transverse wave? Like light wave. Okay, light wave is the example, is the most common example of transverse wave. You can say electromagnetic wave, and in case of in electromagnetic wave there are a lot of classifications within electromagnetic wave, right? Like X-ray, gamma ray, microwave, light. Okay, this kind of a lot of varieties are there in between transverse or in between electromagnetic wave. And longitudinal wave, what is the example? That is sound wave. Now what is the type, means how you can distinguish between transverse and longitudinal wave? So let's see. This is my pen, right? This is my pen. Now if this pen is to move along this direction, first of all let's consider this is the wave. Wave means something which is oscillating like this, right? Wave, some wave. So this wave is vibrating like this object is vibrating like this. Now it is vibrating like this and it is moving along this side. Just see, it is shifting, the whole plane is shifting. Okay, it is oscillating or vibrating, and along with that it is also shifting, its position is changing. So this kind of wave is known as transverse wave. Means just see, along this direction it is vibrating, but movement is along this direction. Means if you take x and y axis, then along y axis if it is vibrating, then movement is happening along x axis. Or rather, even you can consider that along x axis it is vibrating and movement is along y axis. This kind of things, this kind of waves are known as transverse wave. Then what is longitudinal wave? Like this pen, same pen I am taking, and now this pen is vibrating like this, okay, like this. And also just see along which direction it is moving. See along which direction it is moving, along upward, or even you can see that along downward. Now it is moving. So along the vibration direction, along the direction of vibration, if it propagates means what? Movement of wave is known as propagation. Okay, propagation, the word, this term is new for you. So propagation is what? Propagation is what? The movement of waves, movement of wave. Okay, any wave when it is moving along which, in whatever it may be transverse wave, maybe longitudinal wave, but along which direction, or means movement, just movement is happening, is known as propagation of wave. Okay, now if that propagation of wave is along the vibration direction, means if let us suppose this is x-axis, this is y-axis, along x-axis it is moving, and it is also going, its movement is also along x-axis, means vibration is x-axis, means this is the vibration, and movement is also like this. Along the propagation direction vibration is happening. This is longitudinal wave. Okay, clear? Let's see, let's visualize what is happening in case of longitudinal or sound wave. Means we are now focusing into the propagation of sound wave. Okay, let's come to Google and let's search it. Okay, so I am searching for longitudinal wave. You can see the propagation of longitudinal wave. Okay, let me search GIF animation. Okay, this is also GIF. Just see. You can take any example, but just see what is happening here. What is happening? This wave is vibrating like this, and also movement of this wave is along the propagation direction. This is why it is what? It is longitudinal wave. But here you can see that this point, focus on this point. This point is moving down, up, right? Along this direction, just see. This, focus on this point. This point is sometimes moving up, moving down. Okay, just vibration is like this, but propagation is along the x direction. Okay, propagation is along the x direction. So this is how you can imagine the fact. Now propagation or movement, so you can understand the propagation of longitudinal and transverse wave. Now how sound wave propagates then, right? How sound wave propagates. So let's consider there is nothing, means there is a very uniformly distributed air medium, means where no compression or elongation of molecules or air particles are present, right? So there is no vibration, no movement of the air particles. Now somewhere some sound is producing. Let's suppose from here some sound wave is occurring. What will happen? It will just push this air particles like this, and at somewhere those particles will compress, and this will be compressed by this sound wave. Vibration of this sound wave will compress the air particles, and again after some time this air particles will elongate, and further its energy will transfer to the next level, means next level of particles, and they will further compress, and again after some time they elongate and will transfer their energy to the next level, and and this level will further be compressed by this energy. Again this here it will be elongation, and will this compression energy will be given to the next level. This is how this sound which is producing, which is coming out from the source, will be transferred through this medium by the vibration of the particles. So obviously some particles, some medium is essential, some medium is necessary to pass, right, which will help to pass the particles or pass the energy or pass the sound wave. This is how, with the vibration of the particles like this, sound is propagating along the same direction. This is why the sound wave is known as longitudinal wave, longitudinal type wave. Okay, now let's come to the frequency range, because this is very much important regarding your exam purpose. So as per the frequency range, we can classify any kind of sound wave into three parts. First one is let's come to the audible range at first. Audible range. So audible range is 20 Hz to 20 kilohertz or 20,000 Hz. 20,000 Hz can also be written as 20 kilohertz. Okay, and above this frequency it is ultrasonic. Above this it is ultrasonic sound, or which is greater than 20 kilohertz. Okay, which is greater than 20 kilohertz. And below this it is infrasonic sound, which is less than 20 hertz. A lot of uses are there also. This kind of waves can be used, like infrasonic waves, like we communicate by the audible sound. If I want to call you, then obviously by some name I am going to call you, right? So this is within the range of 20 hertz to 20,000 hertz. But when some animal or some like some insects are trying to communicate with one another, then they use infrasonic sound, okay, which has frequency less than 20 hertz. So some insects or some animals can also communicate by using this infrasonic sound. And audible is for us, means for human being, audible sound, and ultrasonic sound is for which is having frequency greater than 20 kilohertz. And ultrasonic sound is used for where its uses is means a lot of uses are there, like USG. You have heard USG, like ultrasonography, right? Ultrasonography means what? If some let us consider that this is some organ. I am not saying that this is bone, just I am saying this may be some organ. Now this is the normal organ, and this is the same organ but having some defect here, having some defect at this portion, okay, at this portion. Now what will happen when USG or ultrasonography, this is the source, and here detector and source both are present, okay, and source detector may be present at this side also, no problem. At this side also may be some detector. Now this is the source of ultrasonic sound, and what is happening, some kind of ultrasonic sound is sent like this, and will directly return after reflection. Means sound wave also can reflect. I am coming into that point, but before that I am just trying to feel you that what is happening actually. So in case of ultrasonic wave or USG, they are sent means ultrasonic sounds are sent to the human body parts, and they are reflected back and are detected to the detector. If there is nothing serious, then all the things will be okay, like a normal case, okay, this is known. This is the known case. Now if somehow some waves is throwing and it is reflecting, but here for this case, since some crack or something, some failure is there, this is why what will happen, it may pass through it, or there might be some lag of reflection, right, lag of coming out of that reflected wave. So this is how easily one can detect that there is some failure or some fault in that region, that particular region. So this is how USG works actually in case of detection of some failure or fault or crack inside your body part. So this is the USG, this is the work of USG or ultrasonography, where ultrasonic sound wave is used, and we can't hear this kind of sound wave because its frequency range is greater than 20 kilohertz. Okay, our audible sound frequency range is less than 20 kilohertz. This is why we can't hear this kind of things. Now, so USG can all be used here. Ultrasonic wave can also, so it is basically the medical purpose, right? And also ultrasonic wave can also be used in construction purpose. Same way, by the same way it is used, but it can be used in construction purpose. Okay, means a pillar is there, or some like a railway track, there is a railway track. Okay, railway track. Now what is happening, if there is somehow some crack is there in between the railway, then what will happen? Rail accident may occur, but to prevent that accident, we can previously cannot see the fault inside that. Means, let us suppose this is the railway track. Now inside this railway track somehow some crack is there. So how you can detect? A layer outside it is okay, no defect from the outside, but when internally some crack is there, so how you can detect? So for that detection you have to basically go to internal part, you have to go to the internal region to detect that fault. So ultrasonic wave then helps to go into that much deeper and help to detect the fault or crack inside the track or inside the construction. Okay, some beam is there which will protect whole building to break or to damage. Okay, so basically this is how we can detect the failure or crack inside the beam or inside the railway track or anything it may be, which are means most important or vital things. For that case we can internally go by using ultrasonic wave, and we can easily check. So construction, medical purpose, these are the most important things where ultrasonic sound can be used. So these are the basic facts. Now basically reflection property of sound. Reflection like light ray also reflect. You know already in class 8 you learnt about this. So what is the fact is that if there is a sound reflector, what are the examples, what may be the examples of sound reflector? Like in case of light, there may be a very small reflectors, very small mirror, very small light source. Light is coming like a laser beam, very thin. Okay, it is coming, it can be reflected by a very small mirror and will go away. But in case of sound, the obstacle or the reflector will be of large size, like reflectors. Example of reflectors, if I want to say, then what are the examples of reflectors? Like hill or mountain, like a building, like wall of a building, right? These are the things from which the sound will go and reflect back. So let's suppose this is such kind of a reflector, and sound is sending through this tube somehow. by any process, and what will happen, it will come out like this through this tube. So if it is possible to check that by which angle they are placed, then we can see that this angle of incidence will be equal to this angle of reflection. So this will also means this sound wave will also follow the rule of reflection, that angle of incidence and angle of reflection will be equal, okay, in case of reflection of sound wave. Okay, now let's come to the next topic, which is which is also a very important thing, like some oscillation, you know about, you have heard about the oscillation of wave. Like let's consider this is a wave, okay, this is what, this is a wave. Now it is propagating along this direction, and I am saying about the about simply the transverse wave. Transverse wave I have already shown that transverse means it is oscillating like this, and movement will be perpendicular to this oscillation, means it is oscillating along y direction, and movement of it will be along x direction. This is known as transverse wave. Now here we have to know some things, some parameters, like time period, okay, like time period, amplitude, frequency, this kind of things we need to know here actually. Okay, so what are this? Let's focus into this. So basically, if we consider that this one is a single wave, this one is a single wave. Why this one is a single wave? Means why this part is not a single wave? Why this part is not a single wave? Right? Why I am taking this whole part? Because a single wave means repetition of that wave will produce. Like if I consider the wave is like this, then obviously from this point to this point it is repeating continuously. It is repeating means beside the original wave, if you consider this is the single wave, if you put the next wave like this one by one, then it will give you the actual result. So for this case, what is happening, you can see it is like this whole portion is placed one by one like this, okay, like this are placed one by one. So what is a single wave? Single wave means the reddish portion, like I am saying that this portion, this whole portion is the total wave, and the length of means this is a single wave. From here to here it is a single wave, so it is, we can consider it is one wave, and length of one wave is known as one wavelength, okay, one wavelength. So length of one wave is known as wavelength, okay, is known as wavelength. Wavelength is generally denoted by lambda. You know about the sign lambda. I am saying LAMBDA, okay, lambda. So this is the notation for wavelength actually. And what is amplitude? For amplitude I am saying another thing to better understand actually. I can say here also what is amplitude, but I am coming into that point. At first try to realize physically that what is called amplitude. Let us consider it is a bob or pendulum. You know na pendulum like this. This is a thread or a string. Here some kind of bobs is present and it is oscillating like this, right? So this is a bob and it will oscillate like this. Now if at the left side it is going up to this, at the right hand side it is going up to this, so the maximum displacement, okay, maximum displacement from the mean position is known as amplitude. Now it is going over my brain, sir, I can't understand what you are saying. Just see, if I leave this pendulum or if I leave this pen, it is like this now, like this means it is the mean position. mean position means where there is no other force, means if I put it like this, then after some time it will come here, means it is the mean position. Okay, this is the mean position, means after leaving any object or any pendulum, where it will stop is the mean position, where no kind of external force or no kind of unbalanced force is acting on that object, is known as mean position. Okay, so this is mean position. And maximum it can go up to this limit, so the distance of the maximum position from the mean position is known as what? Is known as amplitude. So what is amplitude? Amplitude means distance of the extreme position or maximum position from the mean position is known as amplitude, or even you can denote amplitude as the maximum displacement from the mean position, so maximum displacement from the mean position is known as what? That is amplitude. So here you can see that this wave, this is the vibration, right? This is the vibration, this all are the vibration, and this vibration can go maximum up to this limit, so this range is known as what? Amplitude. This is known as amplitude, and it can be denoted by small a or capital A, but amplitude will be always positive. Okay, amplitude will be always positive, so amplitude is denoted by A. Now you know about the amplitude, about the wavelength. Now let's come to the time period and frequency, right? What is time period and what is frequency? This is very simple. Let's come to the fact, means let's come to the fact of the pendulum. This is very quite simple. Like this is the mean position. Now if you start oscillating the object, then it will at first go here, then will go here, then will go here. So what is the fact? Fact is at first it is going A, means first amplitude, then again returning to the mean position, means again another A, again going to the maximum position, another A, and returning to the mean position. And from here, means this is the end position. Now from here the first pattern will again continue, right? This pattern will again continue. So you can feel that this is like that wave, that one after another they are repeating. Okay, so total path length is what? Is 4a, 4 times amplitude, right? 4 times amplitude. This is the distance traveled by that pendulum per oscillation. This is one complete oscillation. Now if somehow a pendulum starts oscillating from one extreme end, then also it will go here, then will return to here. This is one oscillation. So there also mean position will be somehow at the midpoint, and it is A, so 4a. Right, if it starts from extreme position, then, but here I am considering that the oscillation is producing or occurring from the mean position, so then also it is 4a. Okay, now see, so 4a is the total distance, and this is the complete oscillation, one complete oscillation. So what is time period? Time period is generally denoted by capital T. Okay, it is denoted by capital T, and this capital T, this time period is what? Is the time. Capital T is the time period. Time means for which? For making one single oscillation. So just see, if this is the pendulum, then if it starts from here, then it will go at first this side, then come to this side, then go to this side, then to this side, again here. This is the total oscillation. Okay, this is complete. Again I am repeating, this side, this side, this side, this side. This is what complete oscillation. Now if it starts from here, from this position, it will go to the mean position and it will not stop here, will go further at this side, will go here, again will go to the extreme position. So here to here, this is total one oscillation, and the time taken for this one oscillation is known as time period. So what is time period? Time taken for one oscillation is known as time period, is known as time period. Okay, so this is time period. Now what is frequency and time period? There is some relation. I am coming into that point, but before that, let's discuss about the frequency. What is frequency? Okay, frequency is generally denoted by small f. Okay, and so it may be possible that within means it is taking 2 seconds to oscillate, it is taking 3 seconds for one oscillation, means its time period may be 3 seconds, 2 seconds, 1 second, even less than 1 second. It might be possible, or even it may be possible that this pendulum is oscillating 10 times in 1 second, means within 1 second it is so fast that within 1 second it is oscillating by 10 times. It is possible. So number of oscillation it is producing within 1 second. Okay, means number of oscillations in 1 second is called frequency. Now let's come to the relation between time period and frequency. What is the relation? So you know about time period, you know about frequency, just focus on their definition. What was the definition of time period? That for a single oscillation, what is the time? That is t second, right? So t second is the time period for one oscillation. Okay, t second is the time for one oscillation. Now within 1 second, so in t second number of oscillation is 1. In 1 second, what is the number of oscillation? 1 by t, number of oscillations, right? So in a t second, how many oscillations? 1 oscillation as per definition, because time period is what? Time period is that time period is the time for making one complete oscillation. So t second is taking for one oscillation, in 1 second by unitary method, simply 1 second 1 by t number of oscillations is occurring, and we know that in 1 second the number of oscillation in 1 second is known as frequency. So this much number of oscillations are producing is known as f. So this is the relation f equals to 1 by t. Simple relation between frequency and time period. Okay, so for this class, up to this means this class I am dividing it into 2 parts. So this is the first and basic parts I am discussing. Okay, about the sound chapter number 11. So if it is interesting now to you, then obviously you can like this video, and if you have any doubt or if you need any kind of videos, you can leave a comment also. So if you have any doubt, you can comment on the comment section. So I think up to this it is clear to you. So thank you for the first part, and obviously come to the next part. For there I am going to discuss on echo, which is the most vital and means numerical, from the numerical aspect this is very important part. Okay, so I hope this video is helpful for you. Okay, thank you.